Today we're going to get started on everything you need to know about installing a BigTreeTech SKR 1.4 mainboard, 2209 stepper drivers, and sensorless homing. The BigTreeTech SKR series of mainboards have been extremely popular, and that's mostly because you can try out 32-bit processing on your 3D printer for a very little amount of money. I've been getting a lot of questions on the 1.4 version of the mainboard, both the regular and the turbo. You'll see in a little bit there really isn't a lot of difference in between those two. But it's a lot of questions around sensorless homing and TMC drivers. So we're going to take the next two videos and go over everything SKR 1.4, TMC 2209s, and sensorless homing. There is a lot of information here, so I've done my best to pack everything you might need to know about this configuration into two videos. And those two videos are going to be fairly long. But by the end of this, you should know everything you need to know about setting up Marlin 2.0 to work with your SKR 1.4 and have sensorless homing working correctly. So let's not waste any time and jump right into it. So here are both the SKR 1.4 and the 1.4 turbo boards. Can you tell the difference in between these two boards? Well, they're identical, and the only difference between these two boards, I'm going to go over this more during the Marlin config, is the processor. The regular 1.4 board has an LPC 1768 chip. The turbo board has an LPC 1769 chip. The only difference in between those two chips are 20 megahertz. So with the turbo board, you get 20 more megahertz. The good news is the turbo board is only $2 or $3 more than the regular, so it really doesn't matter which one you get. They're going to be almost exactly the same as far as you know in performance. Now, what is the difference between an SKR 1.3 board and a 1.4 board? So both the non-turbo 1.4 and the 1.3, they both use the LPC 1768 processor. A few things have been consolidated on the 1.4 board. One of the biggest advantages is on the 1.4, they've broken the Z driver into two pin sets. So if you have two Z motors, you don't have to create some sort of adapter for them. You can just plug them right into the board. Also, they have added one constant power plug over here. You can use that for a fan or whatever you wish, but that will be always on. On the 1.4 port, you also do have an additional fan port over here, but I believe it is also constantly on. You can't control it. The only one you can control is this fan 0. That will be for your part fan. On the 1.4, your servo pins have been broken out a little bit more clearly. You can use this for your BL Touch setup now. On the 1.3, you had the max in-stop pins. These are not actually max in-stop pins. You can probably use these for whatever you want. But here we have E0 detect, E1 detect, probably used for filament sensors. Again, you can probably use them for whatever you wish. And then this one here is labeled power detect. So if you have some sort of relay that you want to hook up to detect when you want the power to come on or off, you can control those with those pins. We'll see that more in the Marlin config. But again, we can probably do whatever we want with these pins. Now, because of the relocation with a lot of the stuff on the 1.4 and the things that they've added, they've done away with a lot of the jumpers that were on the SKR 1.3. These jumpers are what allow you to control what the stepper drivers do for all the different smart drivers. On the 1.3 out here, you had the UART jumpers. So if you're using a 2208, 2209, you could run them in standalone or smart mode by using these jumpers. The SPI jumpers and the MS0 through 3 jumpers are the same on both boards. And also these diag jumpers over here. You don't have those on the 1.4 board. These are what you would use to enable sensorless homing for a driver. So if these are on, you will not be able to use an in-stop switch. If they're off, you can't use sensorless homing. So that was a nice feature that was controlled already on the board. You don't have those on the 1.4. And that leads us to an interesting situation. So let's focus on the 1.4 now. So before we get more into the drivers portion, there's two other things I wanted to mention. You do have some pins now on the 1.4 to control some LEDs if you'd like. There is a module they sell for this, so we might go over that in the future. Also, you have a Wi-Fi port. BigTreeTech does sell a Wi-Fi module that is a serial bridge that you can use on this board. So we're going to test that eventually as well. Now, driver info. If you would like to use SPI drivers on this board, you will need to put all of these jumpers on just like they are right now. Whichever driver you want to use, all of these are going to have to be on. So those are for like 2130s or 5160s running in SPI mode. That's the smart mode. So I'm only going to do one because I think it's pretty self-explanatory, but if you want to use some of the legacy drivers like an A4988 or an 8825, you would put all of your jumpers on the pins next to those sets of pins. These are the MS0 through 3 pins. You have to have the bottom one on no matter what if you're using those types of drivers, but then these 3 pins will set your microstepping mode. So if all of these are on, that sets them to high. For an A4988, that's going to be 16 times microstepping. For an 8825, that's 32 times microstepping. So different combinations of these 3 jumpers are going to set your microstepping mode. There are lots of guides out there if you'd like to use a different mode, but if you have any questions about it, I would just put them all on, and then you can adjust your steps accordingly inside Marlin. Now, if you want to use UART mode, that's going to be the mode that we're going to be using on our 2209s today. You want to put the jumper on these 2 pins right here for every driver you'd like to use it on. We're only using 4 today, but I put them on by default anyway. So that jumper has to be on for the SKR 1.4 board. Also, if you don't want to use sensorless homing on a driver, we are going to set up sensorless homing on X and Y, but we're not going to have it on Z and the extruder. If you don't want to use sensorless homing on this board, you're going to have to alter your driver board. So now let's talk about these 2209 drivers. If you're going to order a board from BigTreeTech and you want to use these types of drivers, I highly recommend you order the drivers with it. Not all of these silent boards like this are treated the same or configured the same. On some of the different boards, you might have to alter solder pads or move some pins around differently. The chips are the same, the boards are not. So just go ahead and get the BigTreeTech ones that match your board. You're going to save yourself a lot of headache later. So if you want to use sensorless homing, the configuration we're in right now, you don't need to change anything. Just leave them as is. You don't have to alter any of the pins. You're good to go. Put your heatsink on and you're ready. Now, if you don't want to use sensorless homing, we are not going to be using it on Z or E. Because of the consolidation on the SKR 1.4 board, you now have to alter these pins. On the 1.3 board, we had that diag jumper that we could remove or put on if we wanted to change the state. Here we don't have that option, so we have to remove this pin. You can either just clip it, or you can try to desolder it. So if you're not using sensorless homing and you don't remove this pin, your end stop's going to stay open and your axes will crash. And that could be pretty bad. So again, anything not using sensorless homing, you have to remove this pin to use a 1.4 board. Now for the extruder, leaving this on or clipping this pin, it doesn't seem to matter. It doesn't seem to confuse the extruder at all if you leave this pin in place, but it might not be a bad idea to go ahead and remove it. You just don't want to see an issue, maybe something gets confused along the way and you don't know what it is, and it might be this pin causing it. So it's probably the best just to remove the pins for Z and your extruder. So a couple of final things before we get on to the install. Adding this jumper enables the UART connectivity to the driver, so you can send and receive information from that driver. And on a BigTreeTech setup like this, if you're using their drivers and their board, there's really no reason not to use this mode. The UART allows you to control the reference voltage and the microstepping on the driver. Now you can still use these drivers in standalone mode and use the trim pot on top to set the VREF, but you will have to solder some pads on the bottom of the board to enable that. That will disable the UART ability. If you go to standalone mode, these MS0 through 3 pins, like I showed you before on the legacy drivers, those will now control your microstepping. You do have to be in UART mode to use sensorless homing, but the feedback that is provided to the end stop, which used to be done with a jumper wire, which is now done integrated into the board, is provided by that diag pin. That's why if you're not using it, we have to remove it. And the last bit of information is this jumper right here. This is what controls how your board is going to be powered up. I suggest you just leave it on the VDD pins, these 2 pins on this side. If you want to do some testing and you want to be able to power the board up via USB, you can move it to these 2 pins. But most of the time, it's best practice to not have the board powered up unless we have our power supply turned on. So use these 2 pins. So I just leave it there for most cases. Now let's get it wired up. All of our drivers are on. The Z driver and the E driver do have the diag pin clipped on the bottom. Make sure you have these in the correct position. Your potentiometer on top for the BigTreeTech drivers should go on this side for all of the drivers. So badging down below, potentiometer right there. And when you put your heat sinks on, Just make sure you're not close to those pins that are facing on the top. These pins right here. You don't want to short anything out. Now I've showed you this before, and it's definitely not the recommended method to install one of these boards. On Log, the printer that we're installing today, it has all DuPont connector types. These boards have these JTS style connectors. Don't really remember which model that is, but a lot of printers will have these, but this printer doesn't. So all the connectors that I'm going to use, I just removed this plastic shroud around those pins. So I did it for all the drivers, my probe, my thermistors. It just gives a little bit more pin exposed, and it makes those DuPont connectors fit a little bit more snug. Again, not recommended, but that's what we're going to do today. I am actually going to put these back on at some point because we're going to use this board on another project very soon that has JTS style connectors on the motors. If you're doing something like this with DuPont connectors, just pay extra attention to where the pins are going. Especially on things like your fan, you want to make sure you have positive and negative set correctly, or you might ruin a fan. Also, in this configuration, I'm going to show you this more in Marlin, but we're going to use the E1 pins over here to control our hot end fan. Since we don't have a second heater for a second extruder, we can set this up in Marlin so that it will come on and off based on the temperature of the first hot end. I'll show you more on that later. So let's just start with our motor cables down over on this side. I'm going to cable all the motors identically, so the wire pattern will be the same for all the motors. Then we can decide how the motor's running inside the firmware. So if it's not going the right direction, we can just change it in the firmware instead of swapping the cables around. Makes it just a little bit more consistent. So on mine are blue, red, green, and black. So I'm just going to pick a direction. I'm going to put blue going that way on this side for all the motors. So there's X, there's Y. Here's my right Z motor. Doesn't matter which one of these goes where. There's my left Z motor. It's kind of hard to do this and keep it in the camera because I'm so close to the printer with all the wires, but we'll do our best. And then here's my extruder motor. Then we'll put our part fan over here. Remember, positive is on the side with the drivers, negative's on the other side, so plug it in correctly. And then my hot end fan, I put ferrules on so I could use this extruder 2 terminal here. The positive one is the one closest to the drivers, and the other side's negative. We can screw those down. Hot end fans on, we can go ahead and put on our heater wires. They go right here. Remember, the heaters are not polarized. It doesn't matter which one goes where. Next up, we're going to attach our bed heater wires and our DC input. These two are the most important. Make sure you have these down nice and snug. You want those connections to be as tight as possible. If you're not making good connectivity here, there's enough draw where you can actually burn up these plugs. So you want the positive on this side and the negative on this side. And something that trips up a lot of people on these SKR boards is that the positive and negative for the DC power in are actually flip-flopped. So the bed, it's positive, negative. On the DC in, it's positive, negative. Just double and triple check that when you're installing one of these. You don't want to blow anything up. As with all these projects, if you're using this type of terminal, I highly suggest you put ferrules on the ends of all the wires. You don't really want to put bare wires in there or even soldered ends. Ferrules are much better. Power in is done. Next up, we're going to put our Z probe right here. The signal pin is this pin, the center one is ground, and this one is power. Most of the time on an inductive probe like the one that I'm using, this is a 5-volt probe, brown is going to be your positive, and black is going to be your signal. The blue one should be the negative wire. We can plug in our LCD screen, EXP1, EXP2, and I have a filament runout sensor. I'm going to use this E0 detect set of pins for that. Mine's just an IR micro switch. It's the stock one for the Mark III's, but you do have power and ground, so make sure those are set correctly. You want power, ground in the center, and then signal on the end. And then all we have left are thermistors. These are not polarized. It doesn't matter which wire goes on what pin. So we'll put our heated bed thermistor on right there, and our hot end thermistor right there. And we are all wired up. Now we can move on to the Marlin config. We're going to head out to marlinfw.org. We're going to go to Downloads. We're going to grab the most recent version. We have 2.0.5.1. We're going to hit the zip file. Then we can head to Downloads, and we'll extract our zip. Right-click, Extract All. Let's name it 2.0.5 underscore SKR 1.4. We'll hit Extract. When that's done, it should open it up. I'm going to go ahead and rename this folder as well, so it's a little clearer inside of VScode. So we'll just call it 2.0.5 underscore SKR 1 underscore 4, just so I know the difference. And then we're going to open up VScode so we can edit the configuration. Now, I already have some folders in my workspace out here. That doesn't mean you need to remove them, but it might make it a little more clear if you do. You can right-click and remove these folders, but I want to work with these later. So I'm just going to collapse all of these, and then I'm going to right-click and hit Add Folder to Workspace. And we'll go to Downloads, open our 2.0.5 directory, and then we're just going to highlight this Marlin folder. You need to select the folder that contains your Marlin folder. If you look in here, here's your Marlin folder. That's where your config files are going to be. But we want to go up one level and select this folder. So hit Add. And this is going to pull in all of our Marlin configuration data. You can expand Marlin, and we'll start by building the configuration.h file. You can see that we're on version 2.05. First thing I'd like to do is update the author comment. This will display when you open it up in the terminal. This is just so I remember what I did. I just put my name, the date, and the board I'm working on. So let's just do SKR 1.4. Turbo. We're going to change our serial port to -1. On the SKR boards, doing a -1 should allow it to use that virtual serial interface so you can connect to it with your computer. Baud rate, I'm going to set mine to 11.5200 because a couple of things that I'm currently testing on log communicate at that baud rate as well. You can probably just leave it at 250,000 and you'll be okay. Now we'll configure the motherboard settings, and the easiest way to do this is to open up Source over here in the browser, and we'll open up Core. And here's your boards.h file. If you open that up, these are all the boards that are currently supported by Marlin and the name they use in the code. So let's scroll down a bit. They're usually divided up by processor. We're going to set up the turbo, so we have an LPC 1769. Here's all your 1768 boards. There's the regular 1.3 and 1.4 board if that's the one you're using. Or if you head down to 1769, here's our turbo board. So we'll just copy this one, head back to configuration.h, and we're going to paste it right here. That setting is going to direct us to the correct pins file and the processor that we're going to use on this board so it knows how to configure it. Next up, I like to change up the custom machine name. This is what's going to be displayed on the LCD. Let's just name this one log SKR 1.4. We only have one extruder. I do like to switch the filament diameter, 1.75. This is just in case later you want to use the volumetric settings or the filament width sensor and a few other things in here, but it's just good practice to have this set so you don't have any issues later. The next section is for multi-extruders. We don't have any of that, so we'll just scroll through. Power supply control is a bit different nowadays. It used to be you set it to a 0, 1, or 2 depending on what type of power supply you were using. Now you pretty much just leave them commented out unless you have some special type of power supply. This gives you a little bit of control over the power. We don't have that here, so we'll just keep on going. And then we come to thermal settings. This is where you set your thermistors. This is all the different thermistor options that you have in Marlin. I have an E3D thermistor on my hot end, so I'm going to change temp sensor 0 to number 5. And then on my bed, I have a 1, just a regular 100K thermistor. Notice here you now have the probe setting. That's if you want to use a pin to 2 probe and use that thermistor that's on the probe. You can set that up here as well. That will be in a future video. So let's keep on going. Heater min temps and max temps for an all metal hot end. These should be just fine. 275 isn't out of the scope for a V6. 150 might be a little high on that bed, but I never intend to set it that high, so I'm just going to leave it as is. PID settings, I'm going to leave mine to default. You do need to calibrate these later. The one that it gives you for default that they call Ultimaker, it's actually pretty close to V6. It works decent, but you still do need to run a calibration. PID bed, I'm just going to leave that at bang bang for now. That's pretty much just on or off. It has no PID settings. You can configure that with the configuration command as well if you'd like. Prevent cold extrusion. This is just so you can't extrude any filament. The extruder motor won't turn if the hot end isn't up to temp. It's just another safety feature. As well as max length. You can't extrude over 200 millimeters of filament in one go. It's just to keep you from running a command with like 5,000 on it so it sits there and extrudes forever. This will keep you from doing that. Thermal runaway protection is enabled by default in Marlin. Just leave these alone. Keep it enabled. Homing, most of the time your end stops are going to use X, min, Y, and Z, so you can just leave those default. End stop pull-ups are enabled. If you need to disable them, you can comment out these individually if you'd like. You can also enable end stop pull downs if you need to. We don't need to in this configuration. And end stop inverting, this depends on what type of switch you use. I have standard micro switches for X and Y, and then I have a Z probe. And just because I've configured these so many times, I know how it's going to work. I do still have the end stop switches installed, but in this configuration, we're going to use sensorless homing for X and Y. And if you want to use sensorless homing, you're going to have to set those to false right here. So if you have a previous configuration where they're set to true, if you want to go to sensorless homing, come in and update these to false. But we should be okay for those. I'm going to set Z to true. I have an NPN probe that is normally open on this printer, so the light is off. It is not triggered by default until it touches the bed, and then it goes closed. So min end stop is true, and if that is true, you have to match it with your probe inverting down here. So we'll also set this one to true. You might have to play around with these a little bit, just based on what switch you use. If you need to know what that switch is doing, run an M119. That'll tell you the status. If that's not the correct status, you can flip it right here. Then we come down to driver type. This is where you can set the kind of stepper driver that you're using. By default, even if these are commented out, it assumes that you have an A4988. We are using TMC 2209s, and we're going to use them in UART mode. UART mode allows you to use the software commands. If you run it in standalone, you just put _standalone next to it, and that will allow you to use it in standalone mode. You can't connect to it with UART, so you can't get that diag information, but you can still use the Stealth Chop, the quiet feature if you wish. So we'll just comment out for X, Y, and Z, and E0. And we'll change A4988 to TMC 2209. We'll do that for all four. And that will enable all four drivers. I'll show you in a little bit what the default settings for a 2209 in UART mode is. That's over in configuration_adv.h, but we'll get there in a minute. Now we're down to the axis step per unit. This is the setting that tells your motor how many steps it takes to move a millimeter. This depends on how many teeth you have on your pulley, what type of belt you're using, what type of lead screw you're using, and the extruder gears. What's the ratio on those gears? Some are 3:1, some are 1:1, so you need to know a lot about your printer to be able to set these up. And if I've never showed you this before, the Prusa calculator is a great place to go where you can enter in all your parameters, and then that'll spit out a number that you can put in that configuration file. For instance, I'm running a 1.8 degree motor. That's 200 steps per revolution. My belt pitch is 2 millimeter. My pulley tooth count is 16. I'm running at 16 times microstepping, and the belt pitch is 2 millimeter. So for X and Y, it's both the same. I'll enter 100. Just an example of how you can use this calculator. So for X and Y, we'll put 100 in. I am using two integrated lead screws. They are both 4 start. That's a TR 8x8. So that's 400 steps per millimeter of movement. And I'm using a 1.8 degree extruder motor with Bondtech gears, 5 millimeter gears. I set my extrusion, my E-steps, to about 140. That gets me a pretty good result. Every printer is going to be different, but this is pretty common for a lot of i3 machines. So moving on. Now down to feed rate. That's the maximum speed that an axis can move. I'm just going to leave these at default because most of the time nowadays I set them with commands inside the slicer anyway. These are just the maximums, and they can be altered with a G-code command as well. So we're just going to leave them at default. Same with acceleration. These are maximums. I'm just going to leave them set this way. Again, a lot of slicers are going to adjust these for every print. Also with default acceleration, retract, and travel. So before, those were the maximums that the machine can run. This is what the acceleration will be while it's extruding filament. So it can't go over that maximum of 3,000, but it's going to try to achieve 3,000. Again, the slicer is going to decide a lot of this stuff nowadays, so I'm going to leave them here. But just to tell you what they do, this is acceleration while extruding, this is for while retractions are happening, and this is the acceleration for travel, non-printing moves. Again, default should be just fine for this one. By default, Marlin is currently using junction deviation rather than classic jerk. All the testing that I've done with jerk and junction deviation, it really doesn't matter which one you use. I can't see an advantage from one to the other. It is a setting that needs to be tuned, but the defaults do work pretty well, especially on a Cartesian i3 machine. It might introduce some noise in the part where you see ghosting, but this video is more about just getting up and running. We'll get into tuning things like this much later. So classic jerk, if you want to use that, you can uncomment this. Junction deviation, I'm just going to leave it at the default of 0.013. Junction deviation is actually trying to determine the real junction edge, like when you make a movement around a corner. Jerk is more about instantaneous movements. But they kind of achieve the same result. Again, that's for another video. S-curve, I'm going to leave that off for now. I do hope to visit that in a future video. And then we come down to Z-probe. We do have a Z-probe on this printer. It does use the Z minimum in-stop pin, so we're just going to leave this one defined. If you use another pin, you're going to have to comment this one out and set the pin down here. But we're okay for default for now. Mine is a fixed mounted probe, so we'll remove this comment. You have a lot of different options here, including BL touch and nozzle as a probe, like on a Lulzbot or something like that. But the regular inductive probe will be fixed mounted. Moving on. Now we set the probe offsets. This gives you a little map of what that offset might be depending on your probe's location. If you're to the right and the back of the nozzle, that's going to be a positive setting. If you're to the left or the front, that's going to be a negative setting. My probe, I have a standard Mark III's extruder mount, and on that mount, the offset's going to be 23 on the X. That's 23 millimeters to the right, and it's 5 millimeters behind it. Again, that's probe location to nozzle. Also right now, my setting for Z offset is -0.4. I like to turn on baby stepping so that you can adjust this on the fly if you need to, but this is a pretty good setting if you're using that 1 millimeter zip strip and you have an inductive probe with a bed like a steel sheet or the Mark 42 bed. Again, these are just general settings. Some of them have to be tweaked later, but we should be good for now. I do not have a minimum probe edge. This is the setting that you can use to keep that probe away from the edge of the bed if you have clips or something like that. I just set mine to 0 because I don't have to avoid anything. I can get all the way out there. Probing speed, I'll just leave it default. You can slow that down if you feel like you're not having accurate probes. Same thing with multiple probes. If you do a fast probe movement and then a slow one for accuracy, you can set these here, what speed they travel. Down here you can define that multiple probing, how many times you would like to probe. The more times you do take probes, the more accuracy you're going to have. With this bed and configuration, usually I can just probe once and I'll be okay. But definitely don't be afraid to turn these on if you need to get more accurate results. Scrolling on through, we come down to the invert direction. This is where you can change the direction that the stepper motor is going to turn in. You can either just flip the cable over or you can set it right here. For the motors that I have, all of the defaults are correct. So I've got a false, true, false, and then on an extruder it is also false. So that should work for my config, but if you're spinning in the wrong direction, this is where you change that. Homing direction, -1 is going to tell it to always go in the minimum. If you'd like to home in the maximum, you just change these to 1. Default, again, is good for us. Bed size, mine is 250 in the X and 210 in the Y. My Y minimum position, my nozzle is actually just a little bit ahead of the bed when it homes, so I set my minimum to -2.2. If you're exactly in the front right corner, that would be 0. If it's outside or inside a bit, this is where you'd adjust that. Also, my Z max is 210. Software in-stops, this is what keeps you from going outside of the dimensions of the printer that you set previously. So the software will tell it, no, you can't go past 0 in the negative, or you can't go past 250 in the X or 210 in the Y. You can't go more than that. There's a software in-stop in there for minimum and maximum. Now when you're setting things like Z offset, you might need to go into the negative, so you'd have to disable this feature to be able to set it, but again, this is another safety feature to keep you from crashing. There's really no need anymore to change that in the firmware, just leave it default and you can use the M211 command to turn that on and off if you need to while you're setting things up. So we'll scroll on through. Filament runout sensor, this printer does have one, so we'll go ahead and set it up. We'll take the comment off to enable it. There are a couple other things we have to set up because we're using this, but we'll get to those. Number of sensors, I just have one. My runout inverting, I need to set this one to true. Again, this is just based on the type of switch you use, whether it's closed or open when it triggers. I am using the regular IR type sensor that Prusa uses. After you enable filament runout, you can see this switch with the M119 command, so use that if it's not acting correctly. And now is a great time to talk about pin assignment and how Marlin knows what pin to use on the board and how you tell what number of pin is on a board. And BigTreeTech has done a really good job by documenting these on the backs of their boards. We plugged our sensor into this E0 detect pin right here, so that's pin 1.26. The E1 detect pin is 1.25, and then that power detect pin is 1.0. Again, that power detect pin, you can use it for PSU, or you can use it for power off recovery. So we're going to go for 1.26. Now, how do those pin assignments relate back to Marlin? Well, you have a pins file for each one of these boards. So over here on the left, if we open up source, we can go down to pins, and we'll find our processor. Here's our LPC 1769, and we'll open up our turbo board. But as you can see, there's not much in this file. That's because there's an include in this file for the regular 1.4 board. So the pin assignments should be the same for both boards. They are almost identical. So back over here on the left, we'll close our 1769, we'll open up our 1768, and we'll open the regular SKR 1.4 board. Here's where it'll have all the pin assignments for both of these boards. So this is just for general information, but we are using that E0 detect pin on the board, and we found on the back of the board that that is pin 1.26. That pin assignment 1.26 is what you will use in the pins file. I left a note for you before, but you have to make sure that you remove the diag pin off of that extruder driver, or it's going to cancel out that E0 detect pin. It won't let you use that 1.26 pin because it's already busy doing something else. So most of these pins are going to have a P on the front of them when they get assigned, but let's just do a Control F and let's search for 1_26, that E0 detect pin. And you can see we come down to the first assignment, it assigns it as the E0 diag pin. You can also see the label here, E0 detect. So by default, if there was some situation where you were using stall guard on your extruder, it would automatically assign P126 to the diag pin, canceling out that E0 detect pin. Now we can see the next hit, it assigns it as X max, and then the one below it assigns it as X min. But that's only in the case where this condition is true. We have an if statement here. And this if statement says if X stall sensitivity has been set, meaning we're using sensorless homing on the X driver, which we are. So this condition is true. Then we define the X stop pin as the X diag pin, which if you look up here, X diag pin is set to 129. That's the minimum end stop pin. So when that is set, you can't use that minimum end stop pin. We're using sensorless homing. If you wanted to use that pin, again, you would have to clip that pin off the bottom of the driver or it's going to cancel it out. So we have set the X end stop pin. Now we have another if statement. If the home direction is less than 0, so if you home towards the minimum, which is left on an i3 Cartesian machine, you're going to set X home dir to -1. If you home to the right or the max on an i3 machine, you're going to set home dir to 1. So this is saying if you are homing to the left, that's the minimum direction. Because we're less than 0, it's set to -1, then we're going to define X max pin, which is P_26, that same E0 detect pin that we're using for our filament sensor. So if stall guard for the X is enabled, that's this condition right here, and then if your home direction is to the left or the minimum side, your max pin is going to be set to that P126. And that's the location where you would expect a max end stop pin to be. Again, it is labeled E0 detect, and we are using it for our filament sensor. If your home direction was set to 1, this condition right here, you would hit this else statement, and you would use it as your X min pin. So your E0 detect pin on the board, that 1_26, would be assigned to X min pin. And down here, if you don't have sensorless homing enabled, your X stop pin, your minimum end stop pin, is going to be set to P_29, which is the default minimum end stop pin on your board. So in our case, in our configuration, since we're using stall guard, the P_26 is also defined as the X max pin. But just because it's defined this way doesn't mean we can't use it for something else. So if we hit find again, We'll see it's also being used as the filament runout pin, fill runout pin right here. It's been defined. So since we don't have our configuration set up to use a maximum in stop, it'll fall through and allow us to use it as our filament runout sensor pin. So that's how you correlate what you've plugged into the front of the board, what that number is on the back of the board, and where it gets configured in your configuration inside Marlin. If you came into your pins file and you didn't have a fill runout pin configured, you can just enter it. Just enter a defined fill runout pin and then assign it a pin. Not every board is going to have its pin enabled, but you can probably find the schematic out on the internet somewhere. And just to take it a little bit further, that pin that we saw that was 1_25 right next to our E0 detect, that's E1 detect. So it's assigned to filament runout 2 if you had 2 hot ends, 2 extruders. And then the P1_00 pin, that's the power detect pin on the end that we just looked at. You can use it as your PS on pin or your power loss recovery pin. Again, not really necessary for this configuration, but it should give you a lot better idea of how this all works. Back to configuration.h. And that brings us to the end of part 1. After all that pins file information, I thought you might need a break anyway, and we're almost done setting up our filament runout sensor. We're going to pick up right where we left off in the configuration file in part 2 that will be coming out very soon. Hopefully you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.